Welcome to Farmington High School. This is Mr. Hoopert speaking. It is Unit 8, Note 6, Pythagorean Theorem. Learning target, I can apply the Pythagorean Theorem. So let's talk about this. The Cyclone roller coaster at New York's Coney Island is one of the most copied roller coasters in the world. Since it was built in 1927, 7 copies of the coaster have been built. The first drop is 85 feet tall, and the length from the bottom of the roller coaster to the bottom of the first hill is 147. Use the Pythagorean theorem to estimate the length of the first hill. So what it is trying to do, and it's trying to tell you that you have a roller coaster that drops. Alright? It says the first drop is 85 feet. So this drop from here to here is 85 feet. Alright? Alright, then it says that from the bottom of the roller coaster to the bottom of the first hill. So it's the bottom of the roller coaster out to the bottom of the first hill is 147 feet. Use the Pythagorean theorem to estimate the length of the first hill. So when we have triangles, alright, there's some overlap there, but that green one is something that we can use to estimate. And so how we're always going to find this is straight up and straight down is a height, horizontal distance, those are going to be a right angle every time. So with this right angle, whenever you have that, then you can do what we call Pythagorean theorem, a squared plus b squared equals c squared. So the c squared is always going to be your hypotenuse, which is this side. So if I were to do this problem, I would have said 85 squared plus 147 squared is going to equal c squared. So again, get at your calculator, 85 squared, 7225 plus 147 squared, 21609 equals c squared. So then you got to do some math here. So you're going to get 28834 equals c squared. Now remember, the opposite of a square is a square root. So if you take the square root of such number, you should get 169.81 feet is equal to c. So to drop 84 feet, or 85 feet, and the hill, the horizontal distance is 147 between the bottom of the hill and underneath the roller coaster is 147. You need 169.81 approximately is what the slant's going to be. Alright, let's move over. So Pythagorean theorem, a squared, b squared, c squared. C is always your longest side. Alright, we always talk about it being the longest side. We always talk about it being across from the 90-degree angle. So you just have to figure out how you're going to remember that it's always C. And if 3 sides satisfy the Pythagorean theorem, then they form a right triangle. We call that a Pythagorean triple. If it works in Pythagorean theorem, then it's going to be called a Pythagorean triple. So we look at this. So we know a squared plus b squared equals c squared. We're just going to write that down there. Alright, so it gave me a squared plus 15 squared equals c squared. So 8 squared is 64. 15 squared is 225. This is going to end up being the square root of 289. And this is going to be 17 is equal to c. If we read the directions, it says find the missing length of the following right triangle. If necessary, write your answer as a simplified radical. Every quiz, every time classes take this quiz, about 10 to 15 kids will get a point off every time because they don't leave it as a simplified radical. They make it a decimal. So make sure you're challenging yourself to do that. So I look at this. I see 18 squared plus 24 squared. Alright, I'm finding C, so I know that the C's got to be by itself, because C always stands for the longest side. 18 squared. is 324. 24 squared, 576, plus 576 equals c squared. Good news, this is going to be 900. Looks like that needs to be a 4. Square root of 900 is c squared, square root. So you have 30 equal to c. Alright, I'm going to get rid of those two, so make sure you guys are comfortable solving for those. Alright, so I'm going to hit extend page. So let's try these. Now our formula is a squared plus b squared equals c squared. So this time they gave me 10 squared plus b squared equals 25 squared. So as we know, 10 squared is 100 plus b squared equals 625. So we have two numbers there and then a variable squared. Well, the only way to take the square root of b squared is to get it by itself first. So we need that by itself. So we would subtract the 100 first. Subtract 100. We'd have b squared equals 525. And at that point, that's when you can take the square root of both sides. So you take the square root of both sides, and you would get b equal to 22.9. Alright, then we'll try number 4. This time they left out the a, so I'll replace the b with 11 squared equals 21 squared. A squared plus 121 is going to equal, is it 441? 441. Now you would subtract the 121 first, because once you do that, you're going to have a squared by itself equal to 320. And now this is the point when it's by itself that you can take the square root. When you do that, you get a equal to 17.9. So I just screwed that up twice in a row. Alright, extendo pageo. So what I did wrong is we have 525 here. We're supposed to not have decimal answers, but if you know how to use your calculator and you got those as well, good work. Now, 525, what I would do is I'd have b equal to, and I would have wrote this as square root 25. Now, 525 divided by 25 is equal to 21. So I would have said this is square root 21, and b would equal 5 times square root 21, and that is the best answer because that is a simplified radical. Remember at the top I said we had to leave our answers a simplified radical, and what I did in the black marker there is correct. Alright, so the reason I took out the 25 is I could see that this number has 25. I also know the square root of 25 is 5. So I always look for the perfect squares to reduce things. So when I see 320, I'm probably going to go with a equals, and I'm going to take 320 and divide it by the perfect square of 16. So this is going to be square root of 16 times 20. Alright, now looking at that, I probably would have changed this. A is going to be 4, however, the square root of 20, so I can pull the 16 out front, square root of 16 is 4. Then I'd see that the square root of 20, I should leave in here, but I'm going to write it as 4 times 5. Because when I see square root of 4, I think, well, the square root of 4 is 2. So then I would pull that out front now as well. So we'd have a equals 4 times the square root of 4 is 2, and I would leave the square root of 5 in there. So I think the best answer here, instead of 17.9, should be 8 square root 5. And if you put 8 square root 5 in your calculator, it should equal 17.9 as well. So you can check to make sure you reduce the radical correctly. Alright, there's a thumbs up poster in my root classroom, alright, so that you can remember how to reduce radicals. You also just need to ask. Alright? What I did in red and green in the bottom right corner might not make sense to some of you, but that's the way my brain works, so we'll check them. Determine whether the following side measures form a right triangle. So, let's see, how's the yellow look here? I think we're going to run with some yellow. So these are the three numbers. Alright, 20 squared plus 21 squared equals 29 squared. Notice, I wrote 29 by itself right away because I see that it's the longest side. That's the one that has to go by itself. So then you have 400 plus 441 equals 29 squared, 841, and I get 841 equal to 841. So determine whether the following side measures are a right triangle. Yes, it works. That doesn't make sense. It is a right triangle. Let's try this one. 8 squared plus 10 squared equals 12 squared. 64 plus 100 equals 144. 164 equals 144. Not a right triangle. Now on your quiz, one of them, instead of doing 9, 12, 16 in order for us, is going to say 9, 16, 12. But that shouldn't bother you. This is still the longest side, so that has to be the c squared. So then you put the 16 by itself. It doesn't matter what order the numbers is, just pick out the longest side. 9 squared is 81 plus 144, and 16 squared should be 256. And I'm starting to scare myself with how many of these I have memorized. 144 plus 81 is approximately 225, which means 225 and 256 are not the same thing, so not a right triangle. So then I look at this one. What I would do, maybe just circle it. Right? 26 is the biggest number out of those, so I'm going to put 26 by itself. So maybe that's one way for you to try to remember this. 10 squared is 100. 24 squared is 576. Oh boy, I'm still right. 26 is 676. So 676 equals 676. Yes, it is a right triangle. We could probably say it is a Pythagorean triple as well, because those values work for a right triangle, then they work for everything. Alright, moving forward, what is the area of this triangle ABC? Well, good news for you. I know that area of triangles is equal to base times height divided by 2. Right? It wants me to find the area. So I see that the base here is this 12. I see that the height is an unknown. So what I'm going to do is I'm going to look at this problem. I'm going to see 20 is across from the 90, so it is the longest side. So then I need to go 20. That's hard to read. How about this color? 20 by itself is going to equal the height squared plus the 12 squared. Could I have wrote, you can switch this around if you like. You could have wrote 12 squared plus h squared. That's not going to matter. Either way, you got to have 144 plus height squared equal to 400. You're going to subtract 144. Right? This is the only way to get the h squared by itself. So h squared is finally by itself. You get 256. You square root it, and you get h to equal 16. Now, when you do that, I would say I'll come over here. All right, the area is equal to the base 12 times the height 16 divided by 2. So everybody should see that we just solved for that side there. So then you're going to get area is equal to 96. There's no units, so we'll do units squared. right? Area is always units squared. So we can do a lot of different applications with this and set up some other things. A square shopping center has a diagonal walkway from one corner to the other. If the walkway is about 70 meters long, what is the approximate length of each side of the center? So awesome. Is there a way to take a square? I want a square. Nope, square. Look at that. I teach myself new tricks every day. Alright, so that's a square. So this is x. If that's x long, this is x long, this is x long. All four sides are equal in a square. They're all x's. Now, it says a shopping center has a diagonal walkway from one corner to the other. So this corner all the way to this corner. Well, that's kind of cool. And that's 70 meters. So what happens here is you can break this into any triangle you want, but I'm going to draw a red one. Now, what happens here is we can do a squared plus b squared equals c squared. However, since these are both x's, we would do x squared plus x squared plus x squared equals 70 squared. So this is standing for our right angle because we know corners are 90, so 70 is still our longest side. The beautiful part about this is we only have one variable in our Pythagorean theorem, and that's the x squared. So what I would have done is 1 plus 1 is 2x squared is equal to 70 squared. That's about 4,900. To get the x squared by itself, you have to first divide by 2. Divide that by 2, you're going to have x squared equals 2450. Now we square root and square root. X is going to equal 49.5 meters. Now, it didn't tell me to leave it as a simplified radical. Remember, simplified radical is going to have a square root. Has a square root. However, we don't tell Mom to drive 3 square root 8 miles to McDonald's. We usually approximate. So when we approximate things out loud, we're going to want 49.5 meters. That's a very good approximation. Proof of the Pythagorean theorem. So this is pretty sweet. So a lot of people, if I said this side would be 5. Right? If I looked at this length, this is 4, and this is 3. Right? So it's kind of this 5 by 4 by 3 thing. And so what they realized eventually is that the area of one of these, base times height, is 9. And the area of one of these is going to be 16, because 4 times 4 is 16. And then if you took this one, 5 by 5 by 5, this is going to be an area of 25 bricks. So what happened is they started saying 9 plus 16 equals 25. Well, that is actually 3 squared plus 4 squared equals 5 squared. So then they kind of looked at this and said, if you square the side lengths, you are going to get a proof that Pythagorean theorem works. So let's try this. If the perimeter of square 1 is 160 units, so I want to do this right away. 160 units, well, good news for you. 160, and if it's a square, all the sides are the same, so I'll divide it by 4. I now know that all these are 40 units. Then it says the perimeter of square 2 is 120 units. So we're going to take 120 divided by 4, and all of these, this is going to be 30 units. What is the perimeter of square 3? Question for you. On the last slide, it said 3 squared plus 4 squared equals 5 squared. I'm going to do a little shortcut. Miss Johnson probably won't like this, but 30 squared plus 40 squared is going to equal 50 squared. Right? These are Pythagorean triples. All right? So if I multiplied every value by 10, the Pythagorean theorem still works. So 5 times 10 is 50. So I already know that this side length is going to be 50. And 50 and 50 and 50, the perimeter of square 3 is equal to 200 units. Right? So if you did Pythagorean theorem, you would get a right answer there of 200 units squared after you find the 50. All right? So make sure you're working a lot with your calculator. Thank you for listening. Have a wonderful rest.